Okay, so I thought this question would be a pretty easy short question, but it's more complicated than I thought because of the find the equation. So there's more than one answer. So the picture is like this. You have a point here 4, and you have 2 points on the y-axis, and they're 6 units apart. So whatever this point here is, let's say it's 0 lambda, for example, then this point here would be 0, 6 plus lambda. Now, I'm not sure how much freedom you could have here, but I feel like there's potentially a lot. Like, there's the obvious answer where this is symmetric, so this is minus 3 and 3, but I wonder could there even be infinite answers? Because the requirement is you pass through this point and cuts the y-axis at points which are 6 units apart. So there might be some limit on the lambda, but let's see what we get. So the equation of the circle is x squared plus y squared plus 2fg or whatever constant you want to call it, doesn't matter, ax plus by plus c. So if you put in 4, 0, you'll get 16 plus 0 plus 4a plus 0 plus c equals 0. So you'll get 4a plus c equals minus 16. That's our first equation. Then if you sub in 0 lambda, you'll get 0 lambda squared plus 0 plus lambda b plus c equals 0, or in other words, lambda b plus c equals minus lambda squared. And then if you sub in 0 lambda plus 6 or 6 plus lambda, well, it's the same thing, except the lambda is replaced by 6 plus lambda b plus c equals minus 6 plus lambda squared. Okay, let's try and solve these now. So I can cancel the c by subtracting the first two equations. So I'll get 4a minus lambda b equals lambda squared minus 16. 4a minus lambda b, c minus c, and then minus 16 plus lambda squared. And then likewise I can subtract the second two equations. So lambda b minus 6 minus lambda b, so that actually is just going to be minus 6b, which is nice. The c's cancel, and here we get 6 plus lambda squared minus lambda squared. Okay, well, I have the b now, and so I can have the a, and so I can have the c. I wonder if I can simplify this a little bit. Minus 6b equals 36 plus 12 lambda plus lambda squared minus lambda squared. Cancel, cancel. Next now, divide by minus 6. So you get b equals minus 6 minus 2 lambda. So that is the b. Now I shall get the, well, I get next the a. So 4a minus lambda b equals lambda squared minus 16. So that means 4a equals minus lambda squared minus 6 lambda minus 16. So that means a is minus lambda squared minus 6 lambda minus 16 over 4. So that's the a. And then the C is minus 16 minus 4a. So the C will be minus 16 minus 4a, so minus 16 minus 4a. So that would be plus lambda squared plus 6 lambda plus 16. So the C is lambda squared plus 6 lambda. Okay, that's the C. So let me make some more space now. So a little messy, but not the worst solution. Let's put it all together now. Okay. So the equation is going to be x squared plus y squared plus minus lambda squared minus 6 lambda minus 16 over 4 x plus minus 6 minus 2 lambda y plus lambda squared plus 6 lambda equals 0. And lambda is any real number. So let's test this. I'm going to pick a random lambda and see if it crosses at the point 40 and where it crosses the y-axis if they're 6 units apart. So let's test with a random lambda. Test with a random lambda. Let's say equal to 3. So I'll just get my calculator out. Let's see what equation that would make. That would be x squared plus y squared. Okay. And that's 4. So that's minus 9, minus 18, minus 16. Or maybe I should pick a number that doesn't produce a fraction. That might be better. Let's see if that's even possible. No, I'll just stick with 3. It's not really random if I change it afterwards. Okay, so I'm sticking with 3. So minus lambda squared, okay, divided by 4. All right, so that's minus 43 over 4 x plus minus 6 minus 6. So that's minus 12 y. And then plus 27 equals 0. Okay, let's test out with 4 zeros. So I'll go sub in 4 zeros. So that's 4 squared plus 0 squared minus 43. The 4's cancel, minus 0 plus 27. And I do get 0. So that works. Now, where does it cross the y-axis? Well, we have to make x equal to 0. So we have to solve the quadratic y squared minus 12y plus 27. So let's think about solving that. Equals 0. So that's y minus 9 and y minus 3 equals 0. It crosses the axis at 3 and 9, which is 6 units apart. So of course it's not a conclusive proof that I got the right answer, but it's definitely reassuring that if I pick a random lambda, I do produce a circle which meets the criteria of the question. That is, it passes through the point 40 and cuts the x-axis at points which are 6 units apart. And there appears to be an infinite number of circles that satisfy that requirement. And that's the form of the equation of all those circles. So yes, quite an interesting question. I'm very curious to know how many students would have gotten this, because initially when I saw this question I thought it was a typical there are 2 circles that do the job question, but no, infinite many circles here. And I don't see any natural restriction on the lambda. Like, I mean, the lambda could be 0, could be positive, could be negative. Yeah. Quite an interesting question. Okay, let's leave it there.